Good evening, my YouTube viewers. It is Crystal here. I wanted to make you another video. My last video, I discussed how to make a Gibbs sampler in Python and R. And in this particular video, I'm making a Gibbs sampler in Excel because a lot of people use Excel for their work. So they'll have Excel so they can make a Gibbs sampler using Excel. So the first thing we're going to talk about is the iterations. So we have 0 to around 2,000 iterations. I didn't want to make it 10,000 because it's a lot to iterate through. So I just made 2,000 iterations. And then we've got our X variable, our Y variable, our random normal X, our random normal Y. So our X variable on cell B2, you put a 0. And on cell Y2, you put a 0. And then on D, that's your random normal X. So that's going to be the inverse of the normal probability distribution function, where it's going to create a random number from 0 to 1 with a mean of 0 and a standard deviation of 1. And you're going to copy that all the way down to 2002, to row 2002, to give you 2,000 instances of that. And random normal Y is the same thing as random normal X, whereas you have the inverse of the normal probability distribution function with a mean of 0 and a standard deviation of 1, and you copy and paste that all the way down to row 2002. And then you've got your X and your Y variables. So in X row B3, you put the formula $I, $1 plus $I, $5, which is a correlation. So 1 is your mean, which is 2. Mean 1 is 2, mean 2 is 3, standard deviation 1 is 1, standard deviation 2 is 1, and correlation is 0.8. And so $I, $1 is 2, plus $I, $5 is 0.8, and then C2 minus $I, $1, and that's 3 times $I, $3, that's 1, divided by $I, $4, that's 1, plus D3 times the square root of 1 minus $I, $5, which is 0.8, squared, plus $I, $3, and that's 1 squared as well. And then that's what you're going to get and put into B3, and you're going to copy and paste that all the way down to 2002. So for the Y variable, you have a slightly different formula, because the formula for X is going to be the probability of X based on Y, and for Y it's going to be the probability of Y for Y based on X. So for Y it's going to be a different formula. It's going to be equals $I, $2, which is 3, plus $I, $5, which is 0.8, times B3 minus $I, $1, which is 2, times $I, $4, which is 1, divided by $1, $I, $3, which is 1, plus E3 times square root of 1 minus $1, $5 squared, which is 0.8 squared, times $1, $4, which is 1 squared. And then that's what you're going to have for Y, and you're going to copy that all the way down to copy and paste that all the way down to row 2002. And then so for row D, you're just going to have, I think we've already discussed that. I think you're going to have the inverse of the normal probability distribution function, which it creates a random number with a mean of 0 and a standard deviation of 1. You copy that all the way down to row 2002. And for Y, random normal Y, is exactly the same thing, and you copy that all the way down to row 2002. So now after we've done that, we're going to check the sample mean of X, which is 1.98, which is very close to 2, and the sample mean of Y, which is 2.968, which is very close to 3. And we're going to have the correlation between X and Y, which is 0.81, which is very close to 8. And you'll see that it changed whenever I changed it. And I also made some graphs. I made a scatter plot of the X and the Y variables, and you can see the X and the Y variables in the scatter plot. And so that's your 2,000 rows of data. And we made a histogram of the Y variable. And so you can see the histogram that we made with the 2,000 rows of data. But really, now that I think about it, because in the last video that we did, we were talking about the the burn-in period. And so this is going to have a burn-in period of 1,000 rows. So that means the first 1,000 rows aren't going to be relevant because it's going to be the burn-in period. So in theory, what we would do is B1 to 0, 2, and B1 to 0, 2, because that was, we've got to have the burn-in period. And then we'll just put a note here. We'll just put a note right here. And then so what we'll do here, I think that what we'll have to do is we'll have to delete these and redo them. And so And then we'll come over here. And then we'll say so we've got our scatter plot. So I don't know if you noticed, but the scatter plot in this instance is missing 1,000 points because the first 1,000 points are your burn-in period. So now what we'll do is okay, so now we've got the scatter plot, which shows your x, y variables, and then you've got your histogram. And you notice that your histogram looks a lot better than it did before because it's excluding the first 1,000 rows, and your first 1,000 rows are the burn-in because it's supposed to, trying to think, remember what it's called. Well, it's supposed to, I'm trying to think of what it's called. I'll write it in the remarks section. I can't remember right now what it's called, but it's called something. It starts with a C, and I'll write it in the remarks, and so you can know what it's about. So I'm going to go ahead and close this video, because we've talked about everything that we could talk about for a Gibbs sampler in Excel, and we're doing it in Excel, but we're doing the same thing that we did with Python and R, except we're doing it in Excel. So this is something that you can do at work if you want to do it at work, because most people have Excel at work. And what I will do is I will look up that word that I can't think of the name of right now, and I'll be sure and put it in the remarks. So thank you so much for watching my video, watching me make a Gibbs sampler in Excel. And if you like my video, please like and subscribe. And I look forward to making another video for you very soon.